Early humans relied on gestures and basic vocalizations for survival, a system far removed from modern language. Around 2 million years ago, Homo erectus used grunts and hand signals to coordinate hunting and warn of dangers. Fossil evidence suggests their brain size increased by 30%, likely due to social interaction needs. Fire, depicted here, became a focal point for group communication. This primitive exchange laid the groundwork for neural pathways dedicated to complex language processing. The cognitive leap from sounds to symbols marked humanity's first true words. Around 100,000 years ago, Homo sapiens began associating specific sounds with objects, like ugh for water or talk for stone. Neuroimaging of modern infants shows similar activation patterns in Broca's area during this naming phase. This cave painting scene captures the moment when sounds transcended mere noise to become carriers of meaning, forcing the brain to develop specialized memory circuits for word-object associations. When humans started combining words like hunt deer instead of deer hunt, the brain underwent revolutionary changes. Around 70,000 years ago, the emergence of syntax required new neural connections between memory, hippocampus, and processing, prefrontal cortex regions. This cave teaching scene shows how word order began conveying meaning, a cognitive burden that expanded working memory capacity by 40% compared to earlier hominids. As evidenced by fossilized brain case studies, language enabled humans to discuss concepts beyond immediate reality, past events, future plans, and mythical beings. Around 50,000 years ago, this abstraction coincided with a 50% increase in parietal lobe density. The storytelling scene here mirrors modern fMRI studies, showing how metaphors activate both language and sensory brain regions. Cave paintings transitioned from depicting literal animals to symbolic narratives, reflecting this neural upgrade that separated Homo sapiens from other species. Today's brain dedicates 60% more cortex area to language processing than our ancestors 100,000 years ago. The fusion image here contrasts a primal brain scan, left, showing minimal language areas, with a modern one, right, where Broca's and Wernicke's areas glow brightly. This neural rewiring, driven by millennia of storytelling, writing, and complex social interaction, explains why human infants learn language 5 times faster than any other skill. Our brains are now fundamentally structured for linguistic dominance.